This is Mark Anderson for Kellogg Community College, and we are looking today at compositions. And this is part 2 of a 2-part video, and in the first video we plugged values into functions, and then we added, subtracted, or multiplied or divided the functions. But here in this video we're going to be putting functions into other functions. So these are going to be compositions of functions. Now I want you to kind of look at the notation here, and let's kind of take this for example, the f of g of 1. This is actually a two-step operation. The first thing I'm going to do is plug a 1 into g. So this becomes g of 1. This means that for every x in g, I'm going to plug a 1 in for x. So this becomes 2 times 1 plus 7. So 2 times 1 plus 7 is 2 plus 7, which is 9. Now this means that my g of 1 is equal to 9. So what's inside my brackets now, instead of g of 1, is the answer of 9. Since g of 1 is equal to 9, I can now replace the g of 1 with 9. And now I have f of 9. So that means for every instance of x in this problem, I am going to replace the x with a 9. So that's 7 times 9 minus 4. And that would be then 63 minus 4. So the answer is 59. So my f of 9 is 59. Or my f of g of 1 is 59. Now to go and review what I just did in this last minute is I plugged 1 into g, and then I plugged g into f. Imagine I'm going to kind of go back to an old game called Feeding Frenzy, where you are a small fish inside of an aquarium, and imagine you eating something, like you you eat the 1, and that gets inside, and then a bigger fish comes along and eats this fish, which not only has the g, but it also has the 1. So this equation is getting absorbed by the f. So the 1 went into g, and then the g of 1 went into f. And that gave me the answer of 59. I'll do this example below it, where instead of we starting with g, we're going to start with f. We're going to plug negative 2 into f. So this is going to be f of negative 2. And we're going to then plug in for every instance of x and negative 2. So 7 times negative 2. And negative 2, then we'll subtract 4 from that. So this is negative 14 minus 4 is negative 18. So my answer for f of negative 2 is negative 18. So now what I'm going to do is I'm going to have my g of f of negative 2, which is negative 18. And whoops, should use a bracket there to keep consistent. And now that I have a negative 18, I'm going to plug that negative 18 into every instance of g. So this is going to be 2 times negative 18 plus 7. Now, negative 18 times 2 is negative 36, and negative 36 plus 7 is negative 29. So my answer for the problem, my g of f of negative 2, is equal to negative 29. And again, going back and explaining what happened in the last minute, I plugged negative 2 into f, and the f swallowed it and turned it into negative 18. And then g came up and swallowed the negative 18, and then that made an answer of 29 once we plugged the 18 into g's belly, or x in this case. Now, doing numbers is pretty great, but let's actually look at putting a function into the other function. Now we're going to start with g of x, and g of x doesn't have any modification at all, so this 2x plus 7 is going to get plugged in for g of x. So now I have f of 2x plus 7. Now, what this means is that every instance of x in f is going to be replaced with 2x plus 7. And to show you that, I'm going to use a different color here. I'm going to change to green and highlight this equation in green, which means that I am now going to go back to blue. I'm going to take this equation, the 7x minus 4, and plug in the 2x plus 7 into every instance of x. So this is 7, change to green. Whoops. 2x plus 7. and then change back to blue to show you that minus 4. All right, so here's what happened. The f absorbed the g of x equation, so that green 2x plus 7 got put in for the x right here. So I am now going to find a function after distributing the 7. So this is 14x plus 49 minus 4. And that will then give me an answer of 14x plus 45. And this is my f of g of x. This is my new function where the g of x got plugged into the f of x. Now you're probably wondering, well, what's the use of this? Well, let's plug 1 into this equation. And if I do, I get 14 times 1, which is 14, and 14 plus 45 is 59. You can see I can check my answer very easily because I now see on my left-hand side that g of 1 is equal to 59, and f of g of 1 would also give me 59 over here. This only tells me what happens at f of g of 1 at 1 unit, where this can tell me what happens at f of g at any unit, at any value of x. So I could plug 2, 3, 4 to positive infinity and to negative infinity as well, and I can figure out what is the composition of this function actually doing. Now down below, I'm going to kind of do the same process. In fact, I'm going to start off with green, and I'm going to do green because my g of x is green. So this means I'm going to take my f of x and plug it into g. And so my g equation, so I'm going to take my g, which is now going to have the 7x minus 4 into it. I am now going to write my 2, and instead of x, I'm going to then change back to the blue color to signify this equation here, or I should say function, like so. Change back to green, and then I'll have my plus 7. Because my green equation, the 2x plus 7, now has the x inside of it. See, it's the g equation with the f of x inside of it. And now I'm going to use, let's see here, I'm going to use my distribution. So this is going to be 14x minus 8 plus 7, or 14x minus 1 is my g of f of x. Now, what's great about this is let's plug in negative 2, like we did over here, to this equation. If I take 14 and multiply by negative 2, I get negative 28. Minus 1 is negative 29. So this answer checks out. Moreover, I can plug in any values or any numbers that I need to find for this composition. Not just negative 2. I can use any positive or negative integer or decimal or irrational. So it's pretty handy. Pretty handy. And so for the next 4 examples, what I'm going to do is start off with f of g of x and then apply the number 3. So here's what's the power of this. If you end up doing these first and you're pretty solid in your algebra, and I want to color code these, so whoops, I'm going to make this blue and color code this and make this green. So now I can actually show if I'm doing f of g of x, I'm plugging g into f. So my equation will be written in blue, and so the place where I plug in my g of x will be written in green. So the g of x has to plug into this x for f of x. So here's my x minus 3, and what I'm about to write in blue is going to be my other part of the equation, my f. So here I have, as you see, my g of x, my green equation, is plugged into my f of x equation. For every instance of x was replaced by this green x minus 3. Since this is squared, this has to be written twice and has to be FOILed. One of the more common mistakes I've seen on tests and quizzes is that students will just write x squared plus 9, distributing the 2 as if this is a monomial in here, but it's a binomial, so you have to write it twice and you have to FOIL it. So the FOIL would be x squared minus 3x plus 9 plus 4. So x squared minus 6x plus 13 is my f of g of x. Now, there's one of two ways you can do this problem to the right. We can do this like we did before, where you plug 3 into g, so g of 3 is equal to 3 minus 3, which is 0. And then you can plug the 0 into f, so f0, I think there's a video game joke in there somewhere. So f0 is going to be now plugging 0 in for x, so 0 squared plus 4. So my answer is 4, or f of g of 3 is equal to 4. Now that's one way you could have done the answer. Another way you could do the answer is to actually plug the 3 back into this equation. So f of g of 3, since we have the original function over here, we can go 3 squared minus 6 times 3 plus 13. So that would be 9 minus 18 plus 13, which is 4, which is pretty handy. It just depends on, I guess, this method was pretty nice since things turned out to be 0. And this is a great, like if you do it both ways, you're checking your answer, which is pretty nice. And the risk of doing it just this way is that if you messed up the x squared minus 6x plus 13, you'll have no idea if you did it right. So there is some risk in this. Going down below, let's switch the order here. Let's start off with green. Actually, I won't, because my x squared plus 4 is written in blue. So x squared plus 4. And then I'm going to switch over to green here. Because for this equation, I keep saying equation, but I mean function there. For this function, I have now plugged my f of x into g of x. And my g of x is x minus 3. So that blue x squared plus 4 jumped into that x. There we go. So there's my equation right there. Sorry, function right there. So x squared plus 4 minus 3 is then simplified to x squared plus 1. Now again, there's two ways you can do this problem. The one way you can do the problem is plug the negative 1 into f. So you have negative 1 squared plus 4. Negative 1 squared plus 4 is, and this is going to be 5. So that is my f of negative 1 is equal to 5. Then I'm going to take the 5 and plug that into g. So my g of 5 is equal to 5 minus 3. And 5 minus 3 is equal to 2. So my answer of f of g of f of negative 1 is equal to 2. Now, again, that's one way you can do it, which is the way that we did up on the top of the worksheet here. But another way, since you have the formula for g of f of x, since you have this function, what we can do is just plug the negative 1 into that. So negative 1 quantity squared plus 1 is 2, which is that answer there. So I think doing both ways is kind of nice because you can check your answer. But really, to each their own. You can solve these problems by going inside out in each situation. And this has been the composition of functions. And we're going to use this in the next video when we are going to look at inverses of functions and how to write down the proper composition of those inverses. Thank you very much, and I appreciate you watching.